Hello everyone, welcome back to the lab sessions. So you have been listening to the lab sessions for the last 4 or 5 sessions, and you have gone through many products, the dissection of products, identifying the parts, and then looking at the assembly and some of the structure and other things. So we'll continue this discussion today in this lab session. We'll be looking at the functional decomposition of a product. So the product that we have chosen is the table fan, which is a very common product, which most of you have we are familiar, and many of you would have at some point of time opened it up for either for cleaning or for some repair or some other work. So we'll look at this product today and then see how the functional decomposition can be carried out for this product, and how we can use the FAST method, which you are familiar now, that is the function analysis system technique. So how can we use the FAST method for decomposing this product? So the objective of this exercise is basically to understand the functioning of the product. So how the product functions, what are the basic inputs, what is the output, what is the main function of the product, and then look at all the parts and the sub-assemblies. So there are many parts and the sub-assemblies and then main assembly. So we look into those parts, sub-assemblies, and then how they are assembled, and then prepare the parts list and assembly chart, which we do for other products also. The main difference in this exercise is that you will be doing a functional decomposition using FAST methods. So we try to identify the critical path function and then the sub functions associated with those critical functions, and then prepare the FAST decomposition chart and try to identify some of the unwanted functions and all time functions, etc. So that is what we are going to do. So the product that we are going to use is a table fan, which is Usha manufacturer, the company, and then the model is basically the Racer. And you might have seen various forms of this product. So, but the fundamental purpose remains the same. So you need have blades, and you want these blades to rotate in order to get some kind of an air circulation. So the fundamental function remains same, but the way it is assembled, the way the blades are provided, and the shape of the blade and the base and the control. So these things may vary from manufacturer to manufacturer and model to model, but the fundamental the function remains the same. That is basically to provide the uh, basically to provide an air circulation. So if you look at the main function of the product, we can say it is basically providing an air circulation. That's all what actually it does. Whatever may be the model or the make or the model, you will see that it basically tries to provide an air circulation of air in a room, and it can be the direction of the circulation can be changed, the speed can be changed. There are many additional functionalities provided, but primarily it tries to provide an air circulation. And in order to get this air circulation, it actually provides many things. It actually provides a rotation for the blades, and then it generates an oscillatory motion, that is for to change the direction of airflow, and then it actually displaces air based on that, and then it's safety. So in addition to that, in order to provide these things, it has to provide something like safety features, so that it does not hurt the people around that product, and then the blade and other things should be secured onto the assembly. So these are the other requirements to be satisfied in order to get the air circulation happening because of the product. Now we'll see how to do this decomposition. So as I mentioned, so first you need to look at the product, understand the function and features of the product, and then remove the fasteners. Okay, the TA will be explaining to you how to do the disassembly and which are the fasteners to be removed, and how you can take out each part by parts, and then you identify all the parts and their functions. So this is very important. So every part has got some functions to do in the product. So whenever you take out a product or a part, and whenever you take out a part, you need to look at what is the function of that part in this particular product, what actually the part is doing in the product in order to get the main function. So there will be some small functions which actually done by these parts. and then you prepare a parts list and the structure. Okay, structure is basically how they are assembled, sub-assembly, and how it actually contributes to the whole structure of the product. So that is what actually you need to do. And once you have understood this part, so that actually for almost all the products you will be doing these steps. Now you actually try to look at the functional decomposition of the product using the FAST method. So how will you do this? So you know how to do the FAST method. So sorry, I'll go back. Yeah, so the FAST method, basically what we do, we try to draw two lines and then say that okay, this is the product domain. So whatever that happens inside, this is the product domain, and then you will say that something is coming as an input, assumed functions, and then something is there which actually is uh, the output or the required function. So this is the way how you look at, and then we say what is that happening, or we start asking questions. Okay, why something is there, and what happens when you give some input to that, or how, why and how. This is why actually what we do this. I mean, we do the functional decomposition. So we'll start this, and then we try to identify, okay, how is something happening, and why you are giving something. Okay, so you are giving electrical input as electricity as an input. So why are you giving electricity? And then here it is, if you know the main function, or we know the assumed functions outside in both sides, and then we look at this one and then start asking questions, and then try to identify the critical path function. And then when you answering this question, you will be getting the critical path functions, and therefore you will be able to get all the main functions associated with this critical path. And then for each one of these, you will identify additional functions. For example, if you say that rotate blades, you need to know how to assemble blade, or how to fasten the blade, and how to protect user. So all those things come as a sub function. So in this way you will try to get those sub functions, and then you will have some all time functions, then some functions which are necessary for the product, like safety and other aspects will separately come. And then you will be having some unwanted functions sometimes. So sometimes there may be some unwanted functions, and then you need to see what are these unwanted functions, and then how these unwanted functions are tolerated or compensated in the product. That will become as an additional function in the product. So this way you will be able to get all the functions of the product, all the functions in the product, and that is basically the functional decomposition. And this is the FAST method, function analysis system technique. So I want you to go through this product, the decision procedure that will be explained, and then based on that, I want you to prepare this FAST diagram and then submit as a report. So the report format is almost the same as in the previous case also. So you will be having this format which is already given to you. So you will be writing about the main function and a little bit on the history of the product, and then you will be going for the parts list, assembly chart, and finally the FAST method of functional decomposition. So this is what actually expected in the report. So please go through the video that is following this one about how to open the product and how to identify parts, etc. The TA will explain it in detail. So listen to him, and then identify the parts, the functions, and then prepare the function analysis system technique based decomposition. Okay, so thank you. Hope you will be able to do it, and you will enjoy doing this exercise. Bye.
Welcome everyone. Today we will be looking at our commonly used table fan, and we'll also be looking at your kitchen exhaust fan. So we'll be dismantling both the devices, and we'll basically look at the individual components, their subsystems, and their operation as well. So let us start with the table fan first. So this is a slightly older model, right? So it's a 3-bladed design that's quite prevalent, used in all our homes. So typically we have a AC induction motor, what we call as squirrel cage induction motor, single phase motor, that is capacitor start and run. So basically, any single phase motor is not self starting, right? You need an additional starting winding. In this case, of all the motors used in our homes have a capacitor start and run motor. which means the starting winding is going to be engaged even during operation. In industrial applications, typically what they do is they'll basically disengage the starting winding with a centrifugal switch. Since this is a consumer device, to keep the cost down, we have a simplified system. So I urge you to please read about capacitor start and run motors, and also read about motors wherein the starting winding is disengaged by the use of a centrifugal switch. These kind of motors where the starting winding is disconnected are used in pumps and certain other industrial applications. In most consumer grade appliances, the motor is typically a capacitor start and run motor. So that is about the motor. So it's a single phase motor. We have a speed control basically. Speed control can be of many types. So we know the synchronous speed of a induction motor, right? It is 120 F by P. So either by changing the number of poles or by changing the frequency, we can change the speed of the motor. So in this case, what we do is we basically change the voltage. Voltage can be changed either by changing the varying the resistance. We can add a serial resistance to the motor and change the resistance, and then we can create a voltage drop to change the motor speed. Or we can use what is called as a V3F, variable voltage variable frequency drive, VVF, triple VVF drive. So there what we can, it's a slightly more complex system where what we do there is we change the frequency as well as the input voltage to change this motor speed. In this case, in case of a consumer device, we want to keep the cost really low. So basically either we use what is called as a capacitive dropper, or we use a rheostatic or we use a rheostat, variable resistance, to change the motor speed. So now I'll basically go through individual level, and then let us look at the dismantling of the product itself. So beforehand I've removed all the screws just to speed things up. So now let me remove the the guard of the motor, sorry, the guard of the fan. So one key thing to keep in mind is for any consumer device, the number of fasteners that are used, you should always keep it to a minimum. Primarily because the number of fasteners, the more the number of fasteners you have, the assembly time is going to increase, and also the cost is also going to increase. So you will see in many of the connections that we see, we'll make use of snap fits. I'll show you what they are when we talk about the exhaust fan. And then let us start by removing the front guard of the fan. As you can see, holding the entire thing in place. So I need not remove the screw. All I have to do is just loosen up the ring that holds the safety mesh in place, the safety grill, right? That lets me remove the front guard. So you can see it consists of multiple powder coated rods that are resistance welded. So you can see this is mass produced. So all this is resistance welded, and then we do a powder coating, a process called, it's a surface treatment. It is just like painting. Please read about powder coating, wherein what we do is we electrostatically apply a plastic powder. It clings to the surface, and then it is baked in an oven to create a very durable surface coating that lasts for several years. So this is, powder coating is better to painting. Also, if you look at the grill, so the safety standard calls for even our little finger should not enter. So that is another thing. Even if it can enter, you should not be able to touch the blade. So safety is of primary importance because you don't want children poking their hands into the grill. So typically, that's why you will find the spacing is quite narrow. But keep in mind, because we are using a grill, this is going to offer some pressure drop to the fan. So some velocity reduction is expected, but safety is paramount. So we have a safety grill. Now let me proceed by removing the other parts of the fan. So as you can see, this is a slightly older model. So this is a metallic fan. So the blades are what we call stamped sheet metal, and then you need basically very precise machining to get the what we call the dynamic balancing of the fan blade. So the fan, since it is typically, if you look at the operating speed, typically it will be somewhere around 1500 RPM. If you take slip, something like roughly around 1450, that will be the operating speed of the fan when it is running at full speed. So which means the fan itself has to be dynamically balanced. Otherwise, if there are any imbalance, residual imbalance present in the either the motor or the fan blade, the fan will start to vibrate. That's why if any of the blades get bent out of shape, you will find the fan vibrates quite vigorously. Newer fans, the next model that I show basically has an injection molded fan blade, contrary to this fan blade that you see here. So let me first remove the fan blade. So I have loosened all the fasteners beforehand just to speed up the disassembly. So basically you can see this is a multi-part assembly. You can see the components are riveted in place. So basically I have the hub where this collar basically engages the motor shaft here, and then basically there is a screw that holds it in place. There is a small dimple there similar to a keyway that basically locks the fan in place. That prevents the fan blade and the motor shaft from slipping. So it creates a positive lock. Talking about the fan blade itself, so basically it's a 4-part assembly. You have 5-part assembly. You have 3 blades, and then you have a disc here, and at the back another disc with a boss basically, and then all the parts, since you never intend to dismantle this in practice, all are riveted together. And in the manufacturing site, what they ensure is they make sure the tolerances and the dies that they use to make this fan blade are very precise. So as soon as the fan blade is manufactured, it has reasonable dynamic balancing that is controlled through the process. So that is something you should keep in mind. Now let us proceed dismantling the fan further. So now I am removing the fasteners that are holding the back guard to the main motor assembly. So now I have removed it. You can see like the front grill. So it is also constructed of multiple parts, and then you have this ring. Basically, let's take a look at the ring that holds it in place. You can see there are grooves on the ring. There are 2 grooves on the ring. So each groove basically provides So what happens is each groove basically engages the outer ring of each guard. So when we tighten, basically you can see when I tighten this screw, that basically clamps both the guards in place. Now let us proceed with the dismantling. Right. So now let us look at the motor housing first, motor and the oscillation mechanism. Then we look at the speed control. So one thing to keep in mind is, so whenever we are dismantling, it is always a good practice to have a ball and then keep all the fasteners properly in place. So you don't lose any of the fasteners when you're dismantling them. So certain fasteners you can leave them in place. For instance, here I have left them, I have not removed it completely. So I have removed it just enough for it to disengage. So certain fasteners can be left in place. Fasteners which have to be removed, it is a good practice to keep them in a ball. And also, it helps to have small stickers in place so we can label each and every component. So basically, we have to, we'll do a functional diagram later. So it's better to label each component. So it is better to keep each component. So it's better to properly label each component and keep them in a proper order, and then photograph the entire dismantle process so that if we have any doubt, we can always go back and refer when we put it back together. So now let us proceed with dismantling the motor. So beforehand, there are many screws that you'll have to remove to dismantle the fan. To expedite the process, I've removed many of the screws to speed up the dismantling process. So we have a housing. This is the motor housing basically. This is a die cast component. So die casting is a manufacturing process. Please read about it. So this is most likely aluminum die cast, pressure die casting we call it. So it is die cast, and then this is the motor stator. So this is the motor stator and this is the motor's rotor. I hope it's clear in the video. So I'm just rotating the what is called the squirrel gauge induction motor. This is a squirrel gauge induction motor. So I'm basically rotating the squirrel gauge. So please read about the squirrel gauge induction motor. So this is the capacitor that basically is connected to the starting winding. So since as I said earlier, it is a capacitor start and run motor. So basically this temporarily converts, or what we say, it converts a single phase supply that is given to the fan, and then it converts, it creates what is known as a phase lag. It basically makes the motor into a two-phase motor. So it is able to self-start. So basically it creates what is known as a rotating magnetic field. So you need a rotating magnetic field for the motor to self-start. So that is the role of this capacitor. So as the capacitor gets weaker, you will find the fan slows down and you will have to replace this once every 3 years or 4 years. Now the entire motor assembly sits on a bearing. So you can see this revolves. So this is a bush bearing. So it sits on a bearing that bears all the load. And then you have an additional mechanism like this that basically helps in changing the what we call azimuth, the up and down motion, to change the direction of airflow, up or down. Since I have removed the all the wirings, it's able to spin freely like this, but in practice the rotation angle is actually limited. Also, please look at the oscillation mechanism here. So let me remove some of the screws so you'll get a better idea. So basically, the oscillatory mechanism is powered by the main motor itself. So the main motor, you can see I'm basically rotating. You can see it has got a what we call, this is called a worm, 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 and this is called as a worm wheel. So whenever the fan is switched on, the worm engages the worm wheel, and as you can see, this is rotating. Now the oscillation mechanism is not engaged, so it is disengaged now. Now when you engage the oscillation mechanism, this mechanism is broken, so it is not engaged. So in practice what will happen is, when you pull it up, now it is disengaged. So the worm wheel and worm are always in contact. The worm wheel will always be rotating. What happens is, when you press the oscillation on button, that basically locks this shaft that you see here to the worm wheel. So this and this shaft becomes basically mechanically linked. So when it gets mechanically linked, so that basically drives this pinion that is down here. So this pinion once again engages a larger gear, right? It's basically a simple gear train, larger gear, which basically drives the oscillatory mechanism. Now the oscillatory mechanism itself uses what is called as a 4-bar mechanism. So I hope you can see. So just to show you, let me just take out the motor. So during operation, because it is engaged, I am unable to rotate it. Let me just. So during oscillation, you can see, so this behaves like a crank, and the entire fan body behaves like a crank rocker. So basically this is a 4-bar, one of the 4-bar inversion. Please read about crank 4-bar inversion, a crank rocker mechanism. So I urge you to visit, if you go to YouTube, there is a channel run by a guy called Jared Owens, Jared space OWEN. So he basically has done a fantastic animation on the oscillatory mechanism that basically gives a very good glimpse of how the oscillatory mechanism works and how this is derived from a standard 4-bar mechanism. So another thing to keep in mind is gear reduction that goes through. If you look at a worm and a worm wheel, the reason why we use a worm and a worm wheel is it gives you a very large reduction in such a small space, small volume. Because you see the motor runs at typically around 1500 RPM. So, but the oscillatory mechanism runs at much slower speed. So basically you have a 2-step reduction. In the first reduction between the worm and worm wheel, typically somewhere around 1:75. That is the gear reduction, which means for for every 75 rotations that the main shaft makes, that is the worm makes, the worm wheel will rotate once for every 75 rotations that the worm makes. So again, we have another reduction here in series. There are two gear reductions in series. So to give us a very large gear reduction, and which also amplifies the torque. So typically, if you see the fans motor, these motors do not produce very large torque because of the way they are constructed. They do not produce very large torque because the application here is just to move air. The motor runs at a reasonably good speed, but the torque that the motor gives is very, very limited. So this is a feature of all induction motors. So if you need for instance, if you look at a drill, for instance, electric drill, there the application is you need a large torque to basically drill a wall, etc. So, but in this case, the torque requirement is not so high. But if you look, so typically, one of the key things to understand about the gear reduction here is that in addition to basically reducing the reducing the angular velocity of the motor that is available for oscillation, it also amplifies the torque that is needed for the oscillatory mechanism. Typically, induction motors have very low torque because the application here is just to move the air, right? So the torque that is available at the motor shaft is quite low. So we need to basically reduce the motor speed and also increase the torque and also increase the torque. So that is why you have such a large gear reduction here. So you have a two-step gear reduction, as I said earlier. So now let us look at the speed control of the mechanism. So I'm just assembling it back. Okay, now let us look at the speed control. So basically, before we look at the speed control, so let us look at the button layout. So the button layout is as follows. So now let us look at the button layout. So as you can see, there are 4 buttons. So this is a stop button that basically stops the fan, and you have basically 3 buttons for 3 different speeds. So we have the low speed, we have the medium speed, and then we have the top speed. So as you can see, the important thing to remember here is that at any given time, we cannot press 2 buttons at once. So we have an interlock mechanism that basically prevents from engaging 2 buttons at once. So we look at the interlock mechanism when we look at the inside of the mechanism. So now let me dismantle the bottom part of the fan. Now keep in mind this is a slightly older. Now keep in mind this is a slightly older version. So the newer fans have slightly different construction. Now you should also keep in mind this. So these are bottom bushings, and then they are held in place by screws, and the screw that holds this also holds the cover that keeps in place. So basically this is how we can reduce the number of components. So newer fans basically don't even have bushings like this. They have what is called press fit bushings, where you can just press them in place. Now this fan has been used many times, so the electrical wiring is all disconnected. Now let us just understand how this works. So basically I have a resistor here with 3 terminals. So the way this system works is like this. So basically when you need the maximum speed of the fan, the wiring is done such that when you engage the button, the coils are directly connected to the output. So when you need to reduce the speed, you have one common terminal and there is a tapping in between. So this is one large resistance, so it's a coil basically. So it's a coil. So I can basically tap it in the middle, or I can completely use the entire length. If I take half the length, I have half the resistance. If I use the entire length, I have the entire resistance. So if I want the fan to operate at the lowermost speed, basically I'll connect these 2 terminals. You have one common terminal, and then the outermost terminal. When we connect these 2, the entire resistance is engaged, and then we have the lowest speed. When we engage the middle portion of the resistor, which means half the resistance is used, which means half the resistance value, the fan will run at medium speed. When you want full speed, you completely bypass the resistance and you directly connect the windings to the mains. So I spoke about interlock earlier. So you can see here. So you can see these small metal pieces here that basically prevent the other buttons from engaging at any given time. So this we call it as an interlock, and this button basically disengages all the 3 buttons. So whenever you press this, the fan turns off. So this interlock prevents from basically engaging 2 buttons at any given time. So it's basically a safety feature. Now let us put the entire mechanism together. So whenever we dismantle a product, so the first thing you should do is to look at the product label and its specifications. So here you can see the sweep of the fan, it's 400 mm is the sweep of this fan. The motor speed, it's about 1300 rpm, right? This is 1300 primarily because of the slip in the motor. And then it's rated voltage 230 volts, 50 hertz. And then what is the power rating of this motor? So this fan draws about 60 watts when it is running at full speed. And then of course its serial number and other details. So the key thing to mind is please pay attention to the power rating of this motor. So this is 60 watt. For instance, if you look at a electric drill, it will be much higher. It will be 500 watts. It will be 1000 watts. Reason is an electric drill does more work than a fan which simply moves air. Also, you should also pay attention to the operating voltage and frequency, because in India we operate at our grid runs at 50 hertz and the standard voltage is somewhere between 210 to 230 volts. Different countries will have different voltage and frequency ratings. Also, you can basically find the current drawn by the motor by using the formula power is equal to VI cos phi. V is the voltage, I is the current drawn by the motor, cos phi we call it as a power factor. So in this case, we neither know the power factor nor the ampere drawn by the fan, but we can make an educated guess, because since the specification says the fan draws 60 watts, we know the left hand side of the equation power is 60 watts, we know the voltage, and then if we assume a power factor of 1 for this device, basically an induction motor, the power factor will be something like 0.95 for a very good motor. For a slightly bad motor, it will be as bad as 0.8 or even 0.7. But since the power rating is very low, we can assume a power factor of 1, which means power is voltage into current. So through that, you can basically calculate the current drawn by the motor. The reason is you should always plug the appliance into its rated power output. For instance, this fan draws less than 1 ampere current when it is operated. So which means you can comfortably plug this into a 5 ampere outlet. If the power rating of your device is much higher, let's say it crosses 5 amps, then you may need a outlet that is suitably sized. Now let us put it back. Okay. So I've done by hand. Now let me use a screwdriver to tighten it further. So let us put the entire unit together. Okay. So when you're putting together, the key thing to remember is, because you have the handle at the top part, make sure it goes this way, not in an awkward position, because this particular fan allows you to assemble it like this, but the latest devices, the latest models from this company Usha will not let you assemble it that way. So here you have to be careful. So it is always a good practice to basically pay attention to the orientation and the alignment of different components as you dismantle them. Okay. So now that let us put the fasteners back. Also, please pay attention to the direction of the fastener. This fastener has a slot at one side. So this will go either way. So when you put it, make sure it is at the outer end. I'll explain why. Always put 2 diagonal screws first, so you get alignment first. Don't tighten them all the way, because it's still, you can see I've left some play in the system. I'll tell you why. So once we have 2 points, now the entire grill is constrained. Now you can proceed to tighten the other screws. Okay. Now we have tightened all the four fasteners by hand. Now we proceed to use a flat blade screwdriver to fully tighten them. So these are called standoffs. So they are very commonly used in computer CPU assemblies. So these are called standoffs. So you can tighten them. So you can see it has got a hexagonal shape. You can either use a socket spanner, or you can use a simple screwdriver. So now we have put the back part of the grill. Now we have to proceed. Okay. Now you can. Okay. 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 Now we have to make sure that this screw basically engages the blind hole that is there on the shaft. We have to make sure when we put the blade back together that the screw is properly aligned with the blind hole. I hope this is so now we assemble the blade back on the shaft. We have to make sure that this screw, when we tighten it, so let me show it on camera. So when we tighten it all the way, you can see it moves in radially in and out. So this end of the screw should basically engage the depression that is here, the blind hole that is on the shaft. So you have to make sure that both are aligned properly to properly secure the fan blade to the motor. So if it doesn't go, which means the screw is obstructing, so loosen it further. Stop on the motor. So once it is assembled, now I can use a screwdriver to basically tighten the. So basically I need a longer screwdriver with a longer stem. So basically you can tighten the screw to engage it. For now I am tightening it by hand since I don't have a longer screwdriver. Let me show you how to put the grill back together. So this is important. So you don't have to loosen the screw all the way. Just loosen it far enough such that you are just able to slip this ring on the outer such that the groove properly engages the back grill. Once you do that, make sure the screw is at the bottom so it doesn't basically interfere with the user. Make sure the logo is aligned to the front. So basically I'm resting the bottom part of the grill on the groove, so I can basically slip it past. So that's it. Now I have the ring properly engaged. All I have to do is tighten the screw to complete the assembly. So now it is secure. Just make sure it is properly secure. So after you've tightened, make sure it is tightened by hand as far as it go. Don't over tighten it, just enough such that the ring is properly secure, such that it holds both the pieces together. You can maybe give it a slight tug to ensure that it is safely assembled. Another thing which I should mention is the electrical connections, because whenever you dismantle any electrical product, first you should unplug the device, and the most important thing is to basically pay attention to the wires that are inside the system. So you have to make sure if you are removing any of the insulations, make sure it doesn't accidentally touch the body of the fan. In this case, this is a the body of the fan is made of metal, which means it can become electrically conductive. And also you can see there is no earthing pin on this fan, which means if for some reason, if any of the insulation breaks down, the entire body of the fan can become light. So that's a safety hazard. Modern fans, that is why you will have modern fans. Basically, the entire body of the fan is constructed out of plastic for this very reason. So now let us move to the second product. Now let us look at the exhaust fan. In contrast to the previous fan, this is a much more better engineered system, primarily because there are fewer screws that we have to remove, and most of the components are injection molded, and it is much more easier to remove because of the use of snap fits. So we'll see what snap fits is. So first, let us look at the overall design of the fan. So basically, this is the intake of the fan. So you can look at the blade design. Basically, this is the inlet, and then you have a diffuser basically. So this basically improves the efficiency of the fan. So you have a diffuser that basically guides the air into the fan. This also is called as a bell housing. So typically you might have seen in aeroplane engines intake, typically you have such surfaces that basically improve the efficiency. At the other end, at the back side of the fan, typically this is placed outside the building. So the fan basically is installed in the wall. So basically you have to make a square hole, and then basically you will take it. So basically this fan it's installed in kitchen, and then it is placed in the wall. Basically you have to cut out a square hole, and this is put into the wall. You have these baffles or these guards basically that prevents rodents from entering the home. So when the fan is in operation, what happens is, due to the airflow from the back, basically air hits these blades, and then it opens up as long as the fan is in operation. When the fan is turned off, due to gravity, it closes on its own. There is also an additional spring that aids in closing these guards. So we look at the mechanism in detail when I dismantle the system. So that is to talk about the overall system. Now let us start with dismantling the device itself. As I said earlier, there are very few screws to be removed in this fan. If you look carefully here, these are called snaps. So to remove, all we have to do is just put in a flat screwdriver and then slightly give it a gentle nudge, and then basically I can remove the snap. So I can do that for every snap. So there are four snaps, two at the bottom, two at the top. So now it is so easy, I can basically remove the entire bell housing of the fan. So you can see this is one piece molded plastic piece, injection molded plastic piece. It is very light, and also since it is a single piece, it is also smoother. So the aerodynamics is also much better. In contrast to the previous fan that we saw, these fan blades are injection molded, and it is a single piece. So to dismantle this, it's very easy. All we have to do is just rotate this part, loosen it, and once you loosen it, this will come off easily. So to dismantle it, all we have to do is just hold the fan and then loosen the front piece, turn it counterclockwise, so that loosens it. The thing which we should keep in mind is the fan goes counterclockwise. So because it pulls in air this way, it goes counterclockwise. The loosening is also counterclockwise. So this is by design. So once we do that, it is as simple as pulling out the fan from the shaft. So you can see how easy it is to dismantle this fan in comparison to the previous design. In the previous design, you had a projection, a boss with a screw, and then if you recollect, you can see I basically struggled to basically locate the screw in the depression on the shaft. In this case, if you see, there is a notch here. It's in the shape of a V. If you look here, this is the hub of the boss of the extended boss of the fan blade basically has the shape of a V. That basically engages a pin that is mounted on the shaft. So all I have to do is I have to put the blade and it will basically self-correct itself. I don't have to worry about alignment. So it will self-align primarily because there is a ramp here. So when the pin hits the ramp, it basically guides itself and it ends up at the lowermost point. So this is the motor. The motor is, again, it's a capacitor start run and motor. Let us remove the if you see here, the capacitor is basically kept inside this. So it's a 1.5 microfarad capacitor and it's basically tucked away nicely, and you have the other electrical connections here. So basically, in addition to that, you also have a green wire. So this is the earthing wire for the fan body. So this design is much safer and it is much better engineered than the previous design that we saw. Also, you can see here the wire is properly anchored here. So if I were to pull on the wire, so no stress is exerted on the connections. So this is critical for safety. So if I pull on it, I can put as much force as I can. The wire is properly anchored at the base, and then the other part of the wire does not feel any stress at all. So this is primarily to improve safety that this design is used. And you can see they have used what is called as a live hinge here. So this piece does not come off. In the previous design, we saw as and when I dismantled each and every component, it just came apart, which means I have to keep track of where I kept them. I have to keep track of the orientation and all that. So this is like your old pencil box that you might have used in schools. So this entire plastic piece, the housing of the fan, is injection molded, and this sort of a mechanism we called as a monolithic mechanism, and this basically what we call is a live hinge. So basically we call these as live hinges. So basically they help us basically eliminate a revolute joint, and just by deformation of the plastic itself at a very narrow point, you get a very good revolute joint without basically use of an additional pin or other complicated mechanical arrangements. So let me just put it together. Okay, now let us look at the motor itself. Let me dismantle the motor just to show you the motor. You can see, to keep track of the screws here. So always it is a good practice to leave the topmost screw because it is hanging. Remove the bottom screws. So that the motor is hanging by one screw, and then we can finally support the motor. See, I have removed 3 out of the 4 screws that the motor is that is holding the motor, but the motor is still held in place by the one screw. So I have to properly support the motor and remove the final screw. Once I have done that, I can basically now remove the motor because the wire is pretty taut. It's not letting me. Just a second. Yeah. So now the motor is freed from its constraint. You can see I can actually proceed to dismantle the motor. So again, so now let us put the motor back together. So making sure that the cables at the other end are properly put in their channels. Now we basically let us start with mounting the topmost screw, one of the screws. Don't tighten them all the way. Just a couple of turns just to hold it in place. Now it is firmly hanging. Now let us proceed to install the next. So the reason why I am doing this is, if there is any misalignment, I can basically move the housing and make sure I can properly align the mounting holes. Okay, I have done that. Now the last part of the mechanism, let us look at how the guards automatically open and close. So as I said earlier, when air flows, air pressure acts on these blades. It creates a torque on these guards and then opens them. As you can see, all the guards are coupled to each other. The reason why they are coupled to each other is, so we want synchronized motion between all three blades. You don't want different blades moving to different positions during operation. So there is a parallelogram mechanism. If you look at the end here, let me remove one of the blades to show you. You can see these are very flexible because they are made of plastic. This is, if you want to know what material it is made of, you can always look at the mark that is there. Let me look at the main. So if you go around, polypropylene and okay. So it is made of this is either polypropylene or ABS. I'm not sure because I cannot find the marking. So you can see you have a link here that basically again it is connected to a torsion spring here. So the role of the torsion spring is okay. So basically we have this mechanism. As you can see, as I swing this louvre, we call it this louvre or this guard back and forth, you can see this slide moving up and down. So basically what we call this is a crank slider crank. So this is the slider part of the mechanism, and this is the crank part of the mechanism. So you have to look at a slider crank variant, slider crank inversion of a 4-bar mechanism to understand what this exactly is. So when one of the blade moves, it couples the other blades together. So they always move in a synchronized fashion. So putting them back is very easy. Also, you can put them. You cannot put them wrongly. So all you have to do is slightly bend them, locate them in place. Now we have 2 of the louvers assembled. Let's proceed to assemble the third one. Slightly bend them. That's it. Now we have them together. So as you can see, there are no fasteners here. So that is the beauty of using plastics, because they are very pliable, they are very compliant, which means you can exploit that property to get rid of fasteners. So you can see. So from this angle, it is quite clear. So I hope you can see the mechanism clearly here. Also, you can see wherever possible, they have made sure there are no screws. They have all used these snap fits. Snap fits, as I said earlier. So snap fit basically consists of something like a wedge here. You can see here. So it is like a sawtooth, basically a single sawtooth that basically engages a small thin wall like this. That basically gives you the snap fit. So to engage it, all you have to ensure is that it can flex just enough to slide past the projection there, and then it will engage. So let us proceed to put the fan together. You can see the entire fan is a single bearer design. The previous fan we saw, it was constructed out of 5 pieces held in place by rivets. So you can see it is expensive because it is made of sheet metal, and you have to make sure it is properly statically balanced, it is dynamically balanced. In this case, because it is injection molded, the tolerances are much more finely can be controlled. So it will come out properly balanced if the process parameters are properly controlled. And most important thing, you can have, please remember, I spoke about these, the V-shaped design here that allows you to self-locate, that allows the blade to self-locate. All I have to do is just mount it, and then it self-aligns itself. And then you have the front portion of the fan assembly, and then you can see there is an embedded fastener within the fan assembly. So this embedded fastener, what we call as, this is called as a insert. So this is called as an insert. So during molding, what they do is they take a standard fastener, keep it in the mold, and then inject the molten plastic around it. Now this screw, okay, sorry. So how this is manufactured, how this is manufactured is, so you have a metal insert. In this case, you have a bolt that is basically made as an insert within the main component. So what they do is they keep the bolt in the die and then inject molten plastic to basically entrap the bolt in place. So that makes it into a single piece now. So now I do not need a a tool like a spanner or a screwdriver to assemble it. All I have to do is, so the direction in which I should rotate to assemble it is given here. Loosen, go counterclockwise, fasten, go, sorry, loosen, go counterclockwise, fasten, go clockwise. Keep it, hold the fan blade, rotate it, and then tighten it by hand. Just hand tighten it. Now the fan is assembled. Now to assemble the front end diffuser, make sure so the way we assemble this is like this. So we have to make sure the bottom snaps, you first engage them, like so, here and here, and then all you have to do is slightly pull the front end, and then it is now assembled. So all I needed to take this entire fan was just a screwdriver. So that is a good design. So a proper design, even a better design would be not to use a screwdriver at all, but that is something we strive for in design. Thank you.